This is the word answer to Unit 6 test question 5. This question is about a hockey puck which is hit and initially travels with a velocity of 14i plus 22j. I'm asked to find the speed of the puck, the angle of direction of motion between the puck and the unit vector j, state the effects of modelling the ice as smooth, and lastly change the density of the puck from grams per centimetres cubed to kilograms per metres cubed. So I'm going to start the problem by drawing the vector 14i plus 22j. And because I'm going to need it later on, I'm just going to add in my x and y axes, or in fact the I and j axes. Okay, so part A asks for the speed, and hopefully we know that speed is the modulus of velocity, so speed is Pythagoras of this vector here, so it's 14 squared plus 22 squared, and typing this into our calculator we get a speed of 26.08 meters per second. Part B is asking you for the angle made with the j-axis, so it's asking for this angle here. So I'm going to split the vector into its horizontal and vertical components. So the opposite is 14, the adjacent is 22, and now using tan theta equals 14 over 22. And then doing tan inverse of this, I can work out what the angle would make. By typing this into a calculator, I get 32.47. In part C, I was asked to explain how I've used the fact that the ice is smooth. Quite simply, this means no friction. I'm also going to discuss the implications of having no friction, which means there will be no acceleration, I will spell that correctly, which leads to the idea of constant velocity. Part D, I'm asked to change from grams per centimetres cubed and change it to kilograms per metres cubed. So I'm going to times this by some fractions so that I can make this statement correct. So I'm going to times it by kilograms over grams, and I'm going to times it by centimetres over metres. I'm going to need to times by this cubed because we have centimetres cubed here. And in essence all I'm doing is times it by 1. So kilograms, 1 kilogram is 1000 grams. 100 centimetres is 1 metre. So by timesing by these two conversions, I'm going to get the density in the format I want. So 1.4 times 1 over 1000 times 100 cubed equals 1400 kilograms per meters cubed. Last but not least, I'm just going to double underline everything I want the examiner to mark just to make it really clear.